Paper 2, question 4. Sine A is equal to 1 over root 10. And that's important. That has to be, A has to be between 0 and 90 degrees. Is that right? Hold on. Pi is 180, no, so 0 and 45. What else does it tell me? It says find the sine of 2a and the cos of 2a in the form of p over q, where p and q have to be natural numbers. I think this question would realistically say inside in the exam without the use of a calculator. So I'm going to do it here without the use of a calculator. Sine 2a. I've seen sine 2a. I have sine 2a. If you go to your log tables, is the same as 2 sine a cos a. So that is 2 times the sine of a times the cos of a. What do I know about sine? Let me just see. I have my right angled triangle. If this is a, then what do I know? Sine is opposite over hypotenuse. And I guess I could use Pythagoras' theorem here. So root 10 to be squared is equal to 1 squared plus x squared. That is 10 is equal to 1 plus x squared. 9 is equal to x squared. So x is equal to 3. So this one here is equal to 3. Now cos is adjacent over hypotenuse. So that's 3 over root 10. And that gives me 6 over 10 top by top, bottom by bottom. Just throw it into the calculator. That's 3 over 5. So 3/5 there. The next one, what is cos 2a? So again, go to log tables. Have I seen cos 2a? I have. It is cos squared a minus sine squared a. This one doesn't work. I'll just do a different one. Cos squared a plus sine squared a. I prefer writing it like this because this makes more sense to me. So cos a to be squared plus sine a to be squared is, it's the same as cos squared a plus sine squared a. So this is what it looks like in your log tables. Just so you know. Cos a, we said was 3, no. Cos a we said was 3 over root 10. And we want that squared, plus sine is 1 over root 10 to be squared. Top by top, bottom by bottom. So that's 9 over 10 plus 1 over 10. No, minus. Sorry, took it down wrong from the start. Minus gives me 8 over 10. Which is 4 over 5 actually. Give it in its simplest form always. If it doesn't say you can use a calculator, not use a calculator, then fine. Obviously I'd say have that option. I just think inside in the exam they probably would say without the use of a calculator, because they want me to show them that I'm also familiar with what's happening in the log tables. By expressing 3 sine a in the form of sine 2a plus a, find the exact value of 3 sine a. So that's just the same as like sine of something plus something else. So sine of something plus something else is equal to the sine of the first times the cos of the second plus cos of the first times the sine of the second. Okay, so let me just show you what I'm doing there again. They said the sine of, something plus something. Okay, so the sine of something plus something. So what you do is you get the sine of the first times the cos of the second. So sine of the first one times the cos of the second one plus cos of the second times sine of the first. Sine 2a, we actually just found up here, 3/5. Again, it's probably going to say without the use of a calculator. Cos of a is 3/√10. So all of this I'm actually just finding in the part above. Plus cos of 2a we just found, 4/5, times the sine of a they gave me at the very, very start. Obviously feel free to throw it into your calculator. I'm supposed to just give it in this form. I'm just going to go 5/10, top by top, bottom by bottom. That gives me 13. So if you have 9 of something, you know, like think about it. If you have 9 20ths and 4 20ths, you've 13 20ths. So the bottom is going to stay the same. And that's 13. And how does that look? No, not the way they want it. I might just, well, am I allowed to throw into my calculator? I guess I'm not. So what other options do I have? I guess I can try the conjugate, etc. So maybe multiply above and below by √10. Maybe not the conjugate, but like strategically multiplying by the number 1, which is what I'm doing when I'm doing the conjugate. But anyway, so that's 13√10 all over √10 minus 50. Okay. You know, this was right back here. It's just the particular form that they wanted it in. Let me multiply by √10/√10. Express 2 cos squared x plus 3 sine x minus 3 as a quadratic equation in sine x. I was going to say I don't even like the fact that there's cos and sine in the same thing if they want me to do anything with this. And hence find all the values of x where we're between 0 and 360 when x is in radians. Okay. Cos squared. Where do I see a cos squared? Okay, so there's a cos squared. I just need to move this over. So cos squared a is equal to 1 minus sine squared. That's an option. Cos squared, there's another one, but it doesn't go into sine. Remember, this is telling me to write it in sine. So that's gone, and that's the only cos squareds I can find, so I'm back to this one. So cos squared, I'm just going to move this over. Cos squared a is equal to 1 minus sine squared. So 2 bracket 1 minus sine squared a, x, plus 3 sine x minus 3 equals 0. That's 2 minus 2 sine squared x plus 3 sine x minus 3 equals 0. I'm going to replace my sine with a y. Just because I think it might look a bit nicer. This looks too weird to me. So that's 2 minus 2y squared plus 3y minus 3. That is a minus 2y squared plus 3y minus 1 equals 0. Multiply everything by 1 just because I don't, or minus because I don't like working in minuses at the very start here. Minus 3y plus 1 equals 0. Whatever way you want to factorize that. So y minus 1 is one factor and 2y minus 1 is the other. So y is equal to 1 and y is equal to a half. I'm the one that introduced the y into the question, so I need to replace it with what it was. So sine x is equal to 1. I need to find x. I need to find my answers between 0 and 360 degrees, and then I'm going to give my answer in radians because they said, you know, they give the question in radians. So I need to go sine inverse. That's 90 degrees. Okay, so what are the reflective angles of 90 or the linked angles of 90? You have 180. You can always just throw this into the calculator if you want. So I'm just doing my reflective angles here. So 90 is one of my answers. It might be the only answer, but I need to check the reflection angles of 90. So sine of 180. Nope, that doesn't give me one. That's not an option. Sine of 70. That's a -1. No, I'm looking for a 1. And sine of 360. No, we know it's 0. Okay. There's my only answer for x in this situation. I'm going to put it into radians. Alright, and then what I'm going to do is I'm going to go sine x is equal to 1/2. Sine inverse of 1/2 is 30. That's only one of the angles between 0 and 360. What are the linked angles to that? We have so 150. Does that work? Yes, it does. 150 is also an answer. Sine of 210 is also linked to that. That's -1/2. No, and sine of 330. No. Now, obviously, you could use your ASTC rule or CAST rule. I just typed them into the calculator. And x could also be pi over 6 radians and 5 pi over 6 radians. There's all my answers. Those three. We have pi over 4. 90. Sorry, pi over 2. Keep doing that. Pi over 2, pi over 6, 5 pi over 6. There are the three values for x.